Hi everyone, in this video I'm going to explain the intuition behind the formula of R squared, the coefficient of determination. In biological data analysis, whether we are modeling gene expression variable or clinical outcomes or drug resistant phenotypes, we are always interested in understanding how much of the variation in the response variable is explained by the measured factors. Regression is a way to do this, and coefficient of determination is a commonly used statistic that measures the proportion of variance in the response variable explained by the independent variables or the other measured factors, which in turn provide valuable insight on the model's fit and effectiveness. Let's try to decode the formula. So let's consider this biological response variable y as a random variable. In biology, so when we the measured variables are usually inherent to variations due to genetics, environmental factors, or measurement errors, or due to some unmeasured factors. So the variation in the response variable is usually given by the spread of the observations around the mean, which gives the total observed variance in the biological response variable, which is equal to the proportion of the variance that can be captured by the measured variables plus the unexplained variance, which is impossible to measure and could be arising due to some other biological mechanism. So R squared is usually given by 1 minus the unexplained variance divided by the total variance. So how can we calculate this unexplained variance and the total variance? So suppose we are having a fitted model, then the residual sum of squares, which is nothing but the sum of the squares of the difference between the predicted values by the model minus the ground truth, and the total sum of squares is the spread of the observations around the mean. So this is the formula which is used to calculate R squared. So higher the values of R squared indicates better fit, which indicates that the significant proportion of the variance in the response variable is captured by the model, which in turn indicates a stronger relationship. On the other hand, the values are closer to 0 indicate poor fit, indicating that the model is able to capture only very little of the variance, indicating weak correlation. So the key takeaway is that R squared indicates how well a regression model explains the variability in the response variable, and higher the R squared, more the variance explained by the model. And also we can use this R squared for comparing models with different set of predicted variables which are fitted on the same data set. But this should also be used in caution. So the thing is that the model that fit the training data very well may not predict well on the unseen data. So we should always ensure that we use this measure along with other measures uh, for assessing the performance of a model. Thank you.